in nature I've ever been. And I've really connected with Gaia in very deep ways. I can
Wow.
shed more light on that later.
Please do.
Yeah.
Why did you go there? Or like, did it sounds like a spontaneous thing?
Yeah, I don't know anyone more spontaneous than I. Um, it's a whole thing of how I even got to Costa Rica and then how I decided to go to this event called Protopia, where a bunch of
Hmm.
creators and leaders of regenerative projects decided to meet here in on this beautiful plot of land up in the mountains in the middle of nowhere. And today was the last day. People are now leaving, but people were sharing their interesting topics and coming together in workshops and also song and dance and creative offerings and stuff. And it really re-enlivened my hope and love. Yeah, I'll just leave it there. Yeah. And
Yeah.
actually, so there are a few things. Sorry I arrived late. Did you all get started on our topics? Because I have interesting.
No, we were
Not
just
yet,
catching
no.
up. We were just catching up, but I pressed record, so welcome
Ah,
everyone who is listening. I thought it
hello
would be
everyone.
fun to have this kind of report from directly in the jungle from our
Yes.
Yeah.
reporter Bruce.
Yeah, hello. So, yeah, we have us, Tobias, Remo, and I, and the New Paradigm Navigators. We have plans and goals and things we'd want to do, but we also surrender to what wants to emerge and what wants to come. And
Yes.
so, what
Definitely.
really wants to be shared with everyone listening, and to you two gentlemen, I'm unsure if you've read these two books. There is one book, Exploring Mycophi, how we can learn from the mycelium network better ways to organize ourselves and organize finance and organize governance just by observing how the mycelium network works and how it is interconnected and shares resources. And when a tree has surplus and a tree needs nutrients, it communicates through these fungal connections, the roots and just the amazing mycelium that I've only just learned about in the last year. And these individuals, there's a number of co-authors on this. They've subtitled it Mycelial Design Patterns for Web3 and Beyond. And so that also requires talking about what Web3 is for those who don't know. But it is a beautiful little picture book too, and
Mm.
goes into 6
Wow.
core design patterns, learning from the mycelium network. And they also say in the introduction that of they are aiming to avoid the appeal to nature fallacy, that just because something is natural means it's good for us. There are some things that are quote natural that aren't, we don't have to adopt all of it just because it's natural. Some people fall into that with like, oh yeah, all natural medicines and all natural everything.
Mm.
I can explain more on that. But what they mean to say by that is, and I'll read it verbatim, they seek to identify and unpack useful pro-social patterns that could be applied in contexts where they increase collective flourishing.
Hmm.
Mm-hmm.
And I will read the next paragraph. I feel like this should be shared. Everyone should buy this book and read it. And then I'll mention a second book. Mycophi is fundamentally a pluralistic and emergent meme requiring many voices to interweave a polyphonic chorus, including those who came before as well as those yet to come. If you feel the call to contribute to the growing folklore of mycelial solutions, we have included information on connecting with communities of changemakers in the last chapter. We offer this book as one step to an ecology of mind, nurtured in the world of mycelial intelligence and all it has to teach us. There is so much more to be written, experienced, and embodied, and we warmly invite you to join in the exploration.
Mm.
And so it goes into talking about smart contracts and nested NFTs, of DAOs, decentralized autonomous organizations, and how, again, we can learn how we can build a better human society by taking notes from the mycelium network. It's beautiful, it's gorgeous. What does that evoke
Wow.
within you two?
That's super interesting. Learning from the mushrooms how to do things. Um, I've heard a little bit about these mycelial networks before from I'm not sure if the author of the book is this Merlin Sheldrake, because I know he's done a lot of work on mycelial networks. But they're super fascinating, these networks. Like the mushroom, this little thing, you know, underneath are these networks that like stretch for miles. If I remember correctly, it's like the largest organism because it's just so huge. These amazing networks they form.
Covers a
Uh,
planet.
yeah, exactly. But we only see this small part of it. But it's apparently super complicated and intricate systems. So that's interesting.
Yeah, I had when I was in my, let's say, visioning stage, a phase, one of them, I also realized that, nothing to, not too much to back it up yet, but I also realized that when we are kind of designing these networks or collectives or communities, we should take into account how, biology has kind of grappled with the many problems that life has, and how our bodies have, evolved to match the reality that we are in, and then we should apply or try to extract and test and apply this knowledge in our social organisms as well. um, how our own bodies, have these, you know, crazy capable and intelligent, organs and systems, for example, our immune system to deal with reality and all these different, parts doing their own jobs. We don't have just brains, on feet. We have our hearts, and we have our livers and stomachs, and you can it's it's probably hard to explain this to like pure scientists, like unless you're in like systems theory or something. um, but you can extract these functions, let's say symbolically, and then kind of apply them to a bigger organization and see what's kind of missing, or where there are kind of diseases or blockages in this bigger organism, whether it's communications or resources or parasites. All of these things you can kind of extrapolate and use somewhat metaphorically. We call it a metaphor, but maybe it's just our kind of consensus reality that we are used to, looking at this as a metaphor only, or as a kind of a fantasy or imagination. But maybe this is kind of a deeper reality.
Yeah, that's a really interesting point. It also thought about what you said, Bruce, about learning from nature. I mean, most of our drugs that we synthesize are inspired by, I mean, fungi and, plants and stuff like that. So that's where we get it all from, actually. It's not where we thought up these chemical compounds. It's, we find them in nature, and then we dissect them and understand them, and then we create them ourselves. But it's so much is inspired by nature. So I guess it's a constant inspiration.
Yeah, I'll add one more quote from this. There's a lot of really interesting quotes here, but here, mushrooms show us that we are and always have been the interconnected parts of one organism that must create symbiotic ways of coexistence with ourselves and the rest of the natural world to continue surviving on a planet wrought with man-made degeneration. So let's learn from the mushrooms.
Definitely, they're wiser than we are.
And to let you know, I'm about to transition. Things are a little weird. I'm hopping in a vehicle, but I will stay on and participate as I can. There's another book. I will tease now. Maybe we can get into it. I just want to share it for anyone listening, anyone watching the recording. Another book to check out: Green Pilled: how crypto can regenerate the world. Beyond just like all the weird hype about NFTs and the degenerate gambling and all the things that most people hear about with crypto, there's actually the underlying technology of blockchain and the contributions of individuals to create a better funding mechanism called Gitcoin is going to be what's going to regenerate the world. It's beautiful. And so we'll get into that if we can. Just wanted to throw that out there.
Thanks a lot for the reading tips.
Yeah, you can just turn off your video, Bruce, and stay connected when you can.
Yeah, thank you. It's unideal. I would love to be fully here, but there's a lot of spontaneity, and yeah, gonna go trek through the jungle now.
Good luck. Stay safe.
Good luck. See you soon.
Yeah, actually, the last talks I attended or lectures, they talked about similar things. But one of the point that I kind of took away that I really liked was kind of reversing the I would say kind of like reality pyramid. I'm not sure how to call it, but in kind of our academia or science, there's this pyramid of knowledge or of certain fields resting upon each other. So I would say first is like mathematics, then it's physics, then it's chemistry, and then it's biology, then it's psychology, and then finally it's like humanities or even theology, right?
Yeah, the
and you
typical
could
way to
to organize our knowledge, but to also see like what depends on what, without physics we wouldn't have chemistry and other things. And you could argue that there's philosophy, we can kind of interchange maybe mathematics with philosophy and so on, but so this biologist, he like turned it around, and maybe probably it's not like his original idea, but he found a lot of data from neuroscience and from biology to support the other way, to show that actually before you can have biology, you must have like I wouldn't call it intellect, but intelligence. That intelligence presupposes and creativity presuppose biology, for example, or if you really go deep into physics, you will see that physicists kind of say the same thing, that all these building blocks of our universe, they are so precise. All these constants that we have and all these laws that we have, that they are so precise that if you change any one of them, like 10 zeros 1%, the universe wouldn't exist, or it would fall apart.
Right, the alignment.
Yeah, and he was saying this about biology, that this intelligence is not something we think it is. Like seriously, not like scientifically. If you look at these, there's, for example, this kind of like slime kind of organism, like single cell organism, that can learn, that can communicate, and that can transfer like knowledge, like one from one organism to another, like from the same single cell organism to another same single cell organism in the same species, without having any nervous system.
Right.
Without having basically anything besides like DNA, RNA to store the data.
Yeah.
It can learn something, and then it can transmit that knowledge in real time to another organism of its kind, so that that organism will use this knowledge to solve a problem, for example. So that's crazy.
Yeah.
Or bacteria, they build like cities, not just cities, but like metropoles, and there are a lot of like experiments like that, or from neurology, there are lots of weird cases where, for example, people are missing like half the brain or even more than half the brain, but are functioning normally, speaking, living, paying taxes,
Yeah. That's a super interesting thing that you bring up there, Remo. And just to go back to this like hierarchy that you mentioned, that we have like maybe mathematics and physics is like the core one, and then we build the other ones come on top of that, a sort of emergent fields of reality or something. And then at the when we go higher, we get to like economics and fields like this. But this really rests on the assumption that, at the base of reality are these like maybe physical particles that we can describe with physical laws, and we can explain anything by reducing it to that. I guess that's where this idea comes from. And when we explain these particles, that's just mathematics. And yeah, so like we are this complex of particles bouncing around, and somehow that creates our conscious experience, I guess. But this is like, I also heard these examples of from a biologist, and also Rupert Sheldrake talks about this. I mean that, single cell organisms and cells, they behave like, they make decisions, and they're like yeah, they behave like they have free will, like they actually make decisions, not just some machine that somehow mechanically go together to produce us. But it's a very interesting thing.
Yeah, even like evolution has so much, and I know it's for sure. I'm not a specialist. For sure, my knowledge about this is outdated and minuscule. But from reading like philosophers as well as biologists, like Rupert Sheldrake and Bruce Lipton back in the day, and Ken Wilber, of course, he's a philosopher, not an evolutionary biologist, but they have also argued that you can't even explain evolution or species with that model, because for species to evolve from mutations only it's like mathematically impossible. There wouldn't be enough time in the universe for all of these species to emerge. Of course, there are these dynamics, this natural selection as well as sexual selection, and what is it called? Not synchronicity, but synergistic symbiosis.
Uh-huh.
There are these kind of dynamics that are true in evolutionary biology, and you can observe them, and they are definitely factors, in our biosphere, but you can't kind of explain that, biology has simply kind of, if, I don't know, just jumped out somehow of physical matter. You have to, and I guess there is use to this, this certain mindset that we have, kind of reductionistic and looking, from physics upwards, but the data, the experience shows us that it might very well be the other way around, or it could be both. We could have kind of involution and evolution at the same time, which is also a crazy idea.
Yeah. Yeah, it's very interesting. I also it came to my mind again. It's very true what you bring up with this common neo-Darwinian assumption that life evolved through this evolutionary mechanical process of natural selection through these random gene mutations and so on. But I mean, there are a lot of holes that are appearing in this way of explaining things. From many biologists are pointing this out. But it's something interesting too, that coming back to this that you mentioned in the beginning about you know, everything is reduced to mathematics, really. Like that's how we explain everything in reality, really. I worked in my PhD research. My project was interdisciplinary, so I worked within biology, and I come from mathematics, and so I experienced this myself. You know, we were working on a model to model the gene transcription process. Like it's a little mechanism in the cell, you know, when you you know code
tiny.
a little part of the thing, you know, when you produce the mRNA molecules. So we had like this model that we worked on for several months to try to get some equation to describe that. But you know, I included that in my PhD thesis. But there was this emeritus professor who actually read my work, and he came and asked me a bit about the assumptions of this. Like, isn't this extremely oversimplified what you're doing here? You know, and I could just admit yes, because I mean, it's so many factors and it's so complex what's going on in this that I mean, no one can describe that mathematically. It's hopeless. We can do that, you know, when we describe the motion of the planets, or you know, with these models of atoms and so on. But as soon as we get just to this level of, you know,
Complexity.
biology, yeah, then this language breaks down. We cannot use it anymore. So I just think this is interesting also, because I mean, many physicists hold this belief, you know, that as long as we get the right equation in physics, then we're done, you know, everything follows from that. So that's yeah, one. And the other is then, again, this hierarchy is really based on this idea that everything is from, you know, molecules up, but we might as well assume that, you know, consciousness is where we begin, or something like that, you know, and then maybe mathematics is not the core the top of the hierarchy subject anymore.
Yeah, there's this idiom in Christianity, I think. Also that, you know, not only are we reaching for God, but God is also reaching for us. So that again kind of is the same idea that, you know, we can have evolution or involution at the same time, that something is, you know, manifesting itself or embodying, you know, this. I also believe, and I think there are some experiments on this, that life is, I'm not sure how to say it in English, but life is kind of like self-manifesting, you know, that life can kind of create itself, and you can actually, you know, kind of observe or catch that process, how like immaterial kind of substance becomes, I mean, material substance kind of becomes alive, or takes like this life form, like shapes, and starts to like progress towards, you know, like RNA basically. But I won't take poison in that. It's just something I'm remembering from like way back when I researched this a little bit. Yeah, and probably also the negative sides of that too, you know, that we can also wipe ourselves out. But
Yeah.
but I guess the pyramid is true in the sense that what I learned in my kind of mystery school was also that similar to Wilber's theory, that the better way to look at reality is that, and ourselves, is that we are layered. There are layers, and you can say that there are like layers of different thickness, let's say, or mass even, to a degree, and you know, for example, bones are thicker than flesh, and flesh is thicker than you know, the mucus in our body or blood. and then blood is thicker than gas in our body, and so on, and or even that gas is thicker than, let's call it, ether, and so on. That you can kind of look at reality the same way and say, if there wouldn't be any like molecules, there wouldn't be any organisms either. Or if there weren't any atoms, there wouldn't be any molecules. So how Wilber looks at it is that, these layers of existence, they're kind of dependent on each other, and how they go up in inverted commas, is that like every previous level encapsulates the levels like under it, and then adds some kind of emergent quality. And so reality, like if you go kind of up in this hierarchy, you get more complexity, but you get like less, like, so what he calls holons, or these are like, parts or particles that are also part of another whole. So for example, atoms are part of molecules, molecules are part of, um, cells, and so on and so on. And then that doesn't apply only to material reality as well in Wilber's model, but the idea is that like these particles, as you get more into like complex or more later emerged levels, the complexity increases. So, this kind of experience increases. We have more qualia to experience the higher up we go. But the higher up we go, there are less of these parts. For example, there are less molecules than there are atoms in the universe, or there are less, humans than there are ants in the universe, and so on.
Interesting. I'm not familiar with Wilber's theory, but is the idea that these lower level particles also have qualia? It's not something that's just reserved for this more high up the hierarchy, more complex level of that.
Yeah, he agrees, and it's one of like his important kind of distinctions as well, and it's not his, of course, like it's goes back to Vedanta, Hinduism, and it's nothing new really, but he also agrees, yeah, that every like level of complexity, or every holon, which is this part and whole category, has consciousness. It has its own like subjective realm, but also this subjective realm kind of widens the further up you go. You can also, instead of up and down, you can think of like concentric circles. So chemistry kind of involves biology and psychology and all these layers. And then physics, involves all of these layers plus chemistry and so on. So they're kind of like, if you look from like the mass or the quantity, they go this way. But if you look from like complexity, they go the other way,
Yeah, that's a good image. Yeah, I think these types of theories are really interesting. I've been looking in a bit to Alfred North Whitehead, which has also some his theories are along those lines as well, where you also have these actual locations which compress into a whole, these parts, and then you have also some type of hierarchy, which is really interesting. And speaking of this, I would also to stare it a bit to education, because when we learn about this in school, we're taught almost like, I mean, it's a fact that we have figured it out now, that we have this atom model, and that's what at the base of reality, and we teach it as it is a fact. But this is one theory that has become the dominant one, but I mean, it's very far from a fact. And like you mentioned with Ken Wilber and Alfred North Whitehead have very different ideas that looks like they can explain a lot more of our reality better than this model, but it still has been taught like a fact, like this is how it is, you know, not even having the humility to present it as, you know, it's a theory, you know, to explain it. Yeah, also came to my mind.
Yeah, absolutely. And I've come a long way since then, but back then when I discovered Ken Wilber, I thought really that, you know, you should teach this to you should and you could teach this in elementary school in like 4th or 5th grade. You know, it's just because it makes it, you know, it integrates so much of our knowledge, because in our educational system, like everything is so like fractalized or fractured, you know, separated. And I think good, you know, like wisdom or good education actually makes things simpler rather than more complex, you know. And if things are working, you know, if things are simpler, you can understand more. And then in this way, Wilber's models are really, really good. And just a quick side note or footnote, like his model, like this is like, talked about the holarchy. He calls this, like, instead of hierarchy, it's holarchy, because it's not just, you know, top-down thing, but it's also like, you know, ecological or kind of, you know, concentric. It's like involving things or like, you know, it's an integrated system, you know. It's not just kind of a top-down thing. And but besides that, he also talks about these 4 quadrants, which is that we have kind of like the objective, or let's say call it the outside world, and then we have the subjective or experiential or the inside world. So the outside kind of world, you can look, you can experiment, you can investigate, you can, you know, touch and so on. But this inside world, besides your own, you know, experience, you cannot kind of, you know, look into it. Like even if you kind of develop some kind of AI to read other people's, you know, mind, you cannot still know what the other person is like, you know, exactly experiencing. You can't get kind of access into another's, you know, subjective experience without communication. And so there's kind of these 2 distinct spheres. And then he also, you know, if this is like one axis, then there's the other axis, which is the individual and the collective. So there is individual subjective sphere of experience or existence. Then there is collective subjective sphere, which is our culture. So this is kind of, you know, the realm of the humanities and art and even language and all of these things. And then there is also like
That's what we're talking about.
Is it you, Bruce? Okay. He's
Hello,
muted.
yes.
Okay, good to have you back. We were talking about Wilber's kind of models and overall like how to kind of look at reality and the fact that there isn't one theory like we are taught in schools, but rather just a theory and different theories. And regarding Wilber's models, I was just sharing to Tobias the 4 quadrants and the holarchy, and saying that he kind of looks at the world from like 4 different categories. So there's the individual subjective and collective subjective. The last is like the culture, the kind of these, you know, these symbols, the language, the archetypes we kind of use to, you know, look at the world or to kind of make meaning of different experiences and phenomena and even relationships and so on. And then there's kind of the objective world, so to speak. So the one you can measure, the one you can touch. You know, there's the so I wouldn't say individual, but like, how do you call it? Ainsuse mitmus. Okay, let's say there's the like it world, so which is like the objective world, and there is also something he calls like the it in plural. So it is also objective, but it's collective. So it's kind of all the like institutions and the infrastructure we have, or ecology, or the planet. You know, kind of the objective world, but in a collective sense. And it's a bit harder to talk about that, or maybe I just can't express it so well. But for me, like, this model really kind of integrated my worldview, or made everything easier to understand. And back then I thought, you know, we should teach this to kids instead of just like the atomic model, or you know, have some kind of spirituality in brackets somewhere, you know, and not even talk about, you know, the meaning or why there is art or humanities and all these fields of experience.
Yeah, for sure.
Even as much as the mathematics that most schools around the world teach is actually only one form of mathematics. It's only one language of numbers, of symbols, of ways to relate information. And there's actually other fields of math.
Yeah, maybe Tobias, you can talk to us about that. What are you hiding from us?
Yeah, a lot of secrets here. Yeah, a lot of different kinds of math. That's interesting. It would be interesting, Bruce, if you could elaborate a bit what you mean by that.
Yeah. Yeah, I was very quick with that because now things are moving. But there are different universes of math. So set theory, where basically the math that we use is based on set theory. And there's actually different ways. I'm in the back. I apologize. But there are, considering that there are, due to string theory, there might be 11 dimensions. Almost all of our mathematics only considers 4 of the dimensions because we don't understand the others. But there are others. And our reality is emerging from only one aspect of this. I think we live in a multiverse, and it's ever shifting. And there's more to elaborate. I'm really not being clear. And I apologize for all the sound.
No worries.
Yeah, there's for sure a lot of a lot of fields in mathematics that aren't being covered in school, for sure. I can just to touch on what Bruce brought up. Been reading this good book, which is called Love and Math by a mathematician named Edward Frenkel. He's a really interesting guy, but he talks about that he makes an analogy, if I remember it correctly, kind of, if you he compares how mathematics is being taught in like high school. If you compare that to like art, it would be like you were being taught throughout school how to paint the fence. That's the only art lesson you were given throughout the whole of school. You were never shown Picasso or Monet or all these beautiful artworks, you know, that people have created. And he thinks it's kind of the same, that, you know, we aren't shown all these beautiful branches of mathematics in school, which could be taught, because really, like set theory, like Bruce mentioned, it's not I mean, more complex than the stuff we are being taught with derivatives and integral and all this theory. It's actually in a way simpler. It's just that we're more used to the other stuff. So I think, yeah, it's something there that we get this really misconception sometimes about mathematics is that it's about this calculating this stuff, but it's so many beautiful imaginative fields in mathematics that people have thought up that, and it's yeah, we can really get the wrong image of it, I think, from the way it's being taught a lot.
I love how mathematicians like yourself often use, beauty to or aesthetics to describe the field of mathematics. It's, in my middle school experience, we had pretty intense mathematical training. We were like, studying integrals and pretty intense stuff. Shit I wouldn't even dare to comprehend anymore. Even like 8th grade, like mathematics is too much for me. Even 7th probably right now. But back then we were, learning the things that usually you don't even get in university, like first year, you usually go like into it the second year. And that for me, it was like army training. I mean, like I was proud
For
that I
sure.
could do it. Yeah, but it was like heavy discipline. It was like fucking weightlifting, It was like really, really tough. But since we had a really good teacher and we were kind of a realist, or however you call that, like STEM class, we could do it. We had many bright students, but I wouldn't compare it to beauty. But I can imagine like how you can kind of look at, these equations, like when they come together to form kind of a kind of picture or a bigger picture, how this, kind of how I think about it is like music or like sculpture. Like when it finally comes together, all these like separate parts and creates this beautiful sculpture or this symmetry or harmony or even a song, with a beginning and an end, how all these harmonies play together. Like this is kind of what comes to my mind. Like if I try to understand the beauty of mathematics or any field really.
Yeah, and it's really true that this is kind of I mean, common for most mathematicians. I think that I know that there is this sense of beauty that drives you in this work, definitely. And I mean, this also can be brought all the way back to the Pythagoreans that talked about, they really had mathematics at the core of their metaphysics, and they talked about the music, the harmony of the spheres, that went in these mathematical patterns and produced this music that you could hear if you were, initiated enough or something like that.
If you dripped hard enough.
Yeah. But it's there is something about mathematics, the elegance there that is beautiful, I think. And I've been thinking about that too, just to relate it also to music. I mean, the feeling you have when you have like a pure note versus a, out of tune note. You have this feeling when you hear that, when something's out of tune or in tune. It's a very similar feeling when you see that something is like true in mathematics, I think. It's like in harmony in some sense. Just phenomenology, logically, it's a similar feeling. And also it's like really a lot of my colleagues who are like more into pure mathematics than me, and others that I've read about, are musicians as well as mathematicians, and they say like they have a very similar feelings when doing mathematics as when they are creating music, which is like a very different conception than what you're exposed to in school often, right? That feeling is often not conveyed, I think.
Yeah, sadly so. I mean, our teacher, like, he was brilliant. Like, he started teaching like university mathematics like way back in the day, like when he was like 22 and his students were like over 30, most of them. He was brilliant, but you know, besides humor, he was really good at that. He didn't have time to really kind of show us the beauty of mathematics. I think he kind of had it or witnessed it or kind of experienced it, but you know, this school, it's kind of like really like, you know, like a factory, you know.
Yeah.
We are on these, you know, these lines, and you just have to kind of shape the young student and send him out, you know, and it all happens so fast, and there's so much you have to kind of stuff into him that you can't actually, you know, see the big picture
No,
or
and that's
enjoy the
really,
process.
yeah, exactly. And that's very unfortunate that it's like that. That yeah, makes you wonder if there's another way to go about it. Yeah.
Yeah, and then to come back to the Bruce's point, I would think about it as, you know, like in music, there are different scales. You know, we're when like producing now, like most of the music we hear is produced in a certain scale, in a certain concrete like harmony, or I'm not even sure what words to use here. I know there are precise words for this, but that there are other scales to actually produce music in too, which aren't that much like explored, which have basically this scale in music has stayed the same for like, I don't know, like at least 500, if not like 1,500 years or something.
Yeah, that's interesting. Also from a mathematical point of view, because there really is just mathematical patterns to these harmonies in music, which is really interesting. Yeah, definitely. One thing I just wanted to mention in relation to this, since you brought up mathematics, I mean, I fell victim to this way of thinking myself before, but it can also be this like romanticizing about mathematics, you know, that everything is just mathematics, like exaggerating maybe the power of the language too. It's a very powerful language in many ways, but it's easy then to fall into the trap of wanting to explain everything through mathematics also. I mean, it could, this kind of thing can happen, and I mean, it is useful for some aspects, explaining some aspects of reality, but you know, if you take a piece of music and you look at the mathematics of it will, you can discover some interesting mathematical, you know, patterns there, but it's not like listening to the music and taking in the meaning of the musical piece. Yeah.
The last lecture I was moderating a discussion also with Jeffrey Kripal. He also said something like, you know, people kind of assume that, you know, when you're in a certain field, that, you know, physicists assume that you can explain the entire universe away with physics, or if you're in social science, you know, you believe that everything comes, you know, into everything can be explained through like social dynamics, when it's, you know, simply not true. That he believes that, you know, there are phenomena you actually can't, you know, not that we right now that we can't, but you actually will not be able to explain through a certain lens. You know, these, you know, especially when we go into like mysticism and you know, these religious and really deep like phenomena that are related to consciousness itself, awareness itself. You know, there are these phenomena, these states of being, these, you know, even like ways of perception, or let's just call them perceptions, these qualities you can perceive that you cannot even objectify.
Yeah,
you know, that there are,
this is a really important point, I think, exactly. Because it's really so, I mean, just to take another example from my PhD experience, I've been very interested in consciousness for a long time. And I discussed that with my supervisor, who is a physicist. And he was like, yeah, we just have to get like the right equation to explain it. And this is a really common assumption, you know, that we just need to, if we don't understand it until we have a mathematical equation to explain it. And to me, that's just crazy. That's if we don't explain it through a mathematical equation, we experience it, you know, directly. But just to again, like it's very deeply rooted, this want of, you know, everything can be reduced to this that I'm doing. And it's just interesting, this phenomenon, and it's not reserved only to physics, probably, like you mentioned.
Yeah,
well.
that, you know, goes back to the Wilber's model as well, that, you know, you have this subjective sphere that you cannot reduce to anything objective, you know, and it's a really easy, simple meditation that you can go all the way, all the way deep, like, you know, into God, or into who you really are, you know, however you call it, into universe. The meditation is this: simply, you know, ask yourself, who am I? And if something comes to your mind, you know that you are not that, because anything you can objectify, you know, and it's easy, it's philosophical, you know, everything you can observe, you are not, because you are the one who is observing. Because, you know, if you are observing this thing, then you are not this thing, you're something else. And you can do this meditation for years, you can do this meditation for decades, and it just keeps going deeper and deeper and deeper. And the craziest thing is that, you know, like I said, you will reach states. Now, I'm not talking from experience, I'm talking from, you know, secondhand, although I have had some states, but not with this meditation. But you will reach, you know, states of being where you can kind of you know, you can experience yourself as God or universe, or just pure being, even, you know, something that isn't even manifested. You know, when we talk about universe, we usually think about the stars and planets and all this creation, but you can even experience yourself before creation or in between creation. That is crazy. And sorry, you cannot give equations to that. You know,
No.
you can maybe you can paint something. You can say this is 0 and this is 1, you know. But yeah, like you said, you know, with the music, like you can explain it in formulas, but you will not get the essence of the experience of that song when you look at formulas.
Exactly. Yeah, I think this is, yeah, definitely. And yeah, there's just different qualities to reality and our experience that cannot be captured like that. And yeah, this is really interesting. Also, what you bring up, this like meditative path to knowledge. You know, we also discover the world by going inward like that and examining our experience. And I guess that's a little bit the Eastern path to knowledge as opposed to the Western path, where the Eastern path, they they through meditation went within, like empirically, investigated their inner life and gain knowledge that way. Whereas we in the West, we look at the world outside of ourselves more, and then try to create these abstract theories about that. So there's really these opposite paths to knowledge as well.
Yeah, we have to finish soon, but talking about these different ways of, I would say, thinking, or let's say thinking, yeah. There is what I kind of a theory that I like is that one hemisphere, or let's say one way of thinking, this rational thinking, I would say this is kind of for like building systems. So this is kind of for automating things. You learn something and then you don't need to put your attention to that. Whether it's driving or walking or all these motorics or even, thinking and perceiving. Like perception is such an interesting topic, but most of it is automatic. And the simple reason is that we cannot, our conscious awareness is severely limited. It's like, I don't know, 7 bits or something, people have tried to put formula to it, and the rest is all unconscious, it's happening automatically, even breathing and all these autonomous things. But then there is this other form of thinking, which is the conscious mind. And that is for creating these systems. So the other one is running the systems, I would say. But this conscious mind is for creating and for fixing these systems. And even when we look into like scientists and whether it's mathematicians or physicists or whoever, or biologists, the breakthroughs they have, or the ideas, the genius they have, they usually describe it as more as coming from the other side of thinking, much more similar to artists when they have their inspiration, where there's a certain state of being and things just click together kind of spontaneously. It isn't like an active thing. You cannot do it. You cannot do inspiration. You can only receive inspiration. You can kind of become a channel for this then breakthrough or solution, or whatever it is. I would call it catching spirits. I think that's a lot of what art is. We're catching a kind of a spirit and trying to capture it in some kind of form, whether it's canvas or a musical instrument or a book. And yeah, I like this view, and we need both, of course.
But that's a super interesting theme. Yeah, just thinking about our thinking, and like you say, that this new discoveries, creativity is not a conscious thing that we construct. It comes for us through inspiration, and that is like in mathematics, that's how it works. A new mathematical idea, it comes to you. It's not just like you construct it. Music, poetry, and yeah, that's something that I also been touching on in my research proposal now, actually. We're running out of time now, but I think this is a theme that I would love to explore more.
Yeah, I
in
agree.
future conversations.
Maybe we can continue from here next time. And this is something we also had originally planned to go into cognition, and you can't go into cognition without creativity and consciousness.
No, it's all part of it. It's a very, very rich topic as well. So there's a whole bunch we can talk about.
Yeah. Well, it's been inspiring. It's been interesting and engaging, and my time it's 9:30 p.m. So, my engagement is a testament to the quality of this conversation. Usually I wouldn't be able to, express myself, but
At this
I think I
time.
did pretty well.
Yeah, I'm very impressed because you're even 1 hour later than I am. And I'm starting to feel very slow now.
Yeah.
But yeah, thanks a lot, Reem. It's been a very, very inspiring conversation as always. So yeah, I'm looking forward to the next time.
Yeah,
Definitely.
let's pick it up next time, and thanks for everyone who's tuned in. Keep coming back. We'll try to produce this cool content for you.
We definitely
Tune
will.
in.